Hi, in this video, we're going to solve a particular problem which appear in the year 2018. It's a advanced level problem. So first we try to understand the problem that what's the procedure to solve or achieve the result. Okay, let's go ahead. So here, first of all, it is given that there are two property. One is property 1 and property 2. And these two properties are based on the limit. Now, if that given limit had existed and have a finite value, so then the corresponding property will satisfy. Now, here four options are provided. So our job is to find the limit, okay, and test that sin x to the power 2 by 3 mod x mod x, these functions will satisfy that corresponding properties, yes or no. And based on that, we have to select the options. Now here we have to notice that here the problem asks that which options is or are correct. So that means by default it is given that multiple options possibly correct. So let's go ahead and start the analysis from option A onwards. Option 1, it is observed that we have to test for property number 2 for fx equal to sin x. So that's why first recall the property 2. What says limit h tends to 0 fh minus f0 divided by h square must be exist and it should be finite. So first we just consider the function fx equal to sin x. Now notice that we need to calculate fh, f0. So that's why we calculate that fh is sin h and obviously by default f0 must be 0. So therefore here we consider a function gh which is equivalent to fh minus f0 divided by h squared. So this function we just consider it as gh. Why? Because we know if we have to then apply our limit on this function gh. So that's why let's go ahead and consider the function as gh, which is fh minus f0 divided by h squared. So therefore, if we apply the value of fh and f0, we get it as sin h divided by h squared. Now that particular limit, if it is exist, right, h tends to 0, then we can say the property is satisfied. So therefore, we consider the limit h tends to 0 gh. Now we know that, right? This particular limit, that limit h tends to 0 sin h by h squared. So here we recall one property that limit x tends to any particular limit to function if it is multiplied fx and gx, right? It can be easily rewritten as limit x tends to a fx multiplied by limit x tends to a gx. So this property we need to apply, and this sin h by h square can be easily written as sin h by h multiplied by 1 by h, and obviously it will be limit h tends to 0. So therefore this limit can be applied separately on sin h by h and 1 by h. Therefore the given limit can be rewritten as, right, limit h tends to 0 sin h by h and multiplied by 1 by h with the same limit. Now, the first limit, right, limit sin h by h is always equal to 1. That we know, right? Basic identity or the basic limits. So therefore, it is equivalent to limit h tends to 0, 1 by h. And this is a very trivial limit. So it says that if h is approaching towards the value of 0, then obviously 1 by h will approach towards the value infinity. So that's why in this particular case, we can say that, right, the limit doesn't have a finite value, and hence fx equal to sin x will not satisfy the property number 2. Now, we'll recall the property number one. Why? Because for option B, we have to test, right, the property one for the function fx equal to x to the power 2 by 3. But in this particular case, notice that in the denominator, we have mod function. So that's why right limit and left limit possibly we need to apply here. So let's go ahead. So first we consider the function fx x to the power 2 by 3, and then we calculate fh as well as f0, which will be equal to 0, and we redefine the function as we done earlier, that function gh, which is fh minus f0 divided by mod h square root, which will be equivalent to h to the power 2 by 3 and divided by square root of mod h. Now see that the value of mod h will change based on our approaching towards the point from the right, from the left. So that's why here we have to go ahead and test it on the basis of right and left limit concept. Let's go ahead. So here we try to find out the particular limit h tends to 0 gh, and we are worried about the right limit. So therefore, we need to calculate limit h tends to 0 plus gh. Now we all know that, right? That how we calculate the right limit for a function. So we know that limit x tends to a plus fx will be equal to limit h tends to 0 f of a plus h. So this is the concept or definition of calculating the right limit. So here we notice that here h tends to 0 plus. So here basically h is equal to x. So therefore this particular limit, right, can be rewritten as limit. We just redefined another variable k. So k tends to 0, g of 0 plus h. So 0 plus k. That is gk. So this limit we need to calculate. Now obviously the limit k tends to 0 applied here. Let's go ahead. So therefore, we go ahead and write that limit k tends to 0, 0 k, and here k is greater than 0, always. So therefore, what is gk? Obviously, it is k to the power 2 by 3 and square root of mod k. Now here, notice that as k greater than 0, so therefore, mod of k will be definitely equal to k, right? That's obvious, right? So therefore, we say that, right, in this particular case, right, that our limit will be reduced to k to the power 2 by 3 divided by k to the power half, and which is equal to k to the power 1 by 6, which leads to our right limit as 0. Let's go ahead and compute the left limit as well. Left limit, as we performed in the right case, we go ahead and compute limit h tends to 0 minus gh. It will be equivalent to g of minus k with the property that k is greater than 0. Now, what is g of minus k? In the place of h, right, we just substitute h equal to minus k. So if we go ahead and substitute that, we'll find that it will be k to the power minus k whole to the power 2 by 3 divided by mod k. Now, first we understand this mod of minus k concept. So minus k. So what is the definition of mod x? Mod x definition will be mod x is equal to x when x is greater than equal to 0, and minus x when x is less than 0. So here it will be minus k with the property that minus k is less than 0. Okay, why? Because see that k is greater than 0, so therefore minus k will be less than 0. Now as minus k will be less than 0, so therefore it will be minus of minus k, because here x is equal to minus k, so therefore it will be k again. So we can directly write it as k, and that's very obvious, right? That's it. But here the main catch, or the sometimes it will be need to be remember that we cannot write that minus k whole to the power 2 by 3 is equal to minus of k 2 by 3. Okay, this is not the right way, or this is not the right operation. Okay, why? Because see that right here, we can write that as minus 1 whole to the power 2 by 3 into k to the power 2 by 3. No problem in that. But this one, right, definitely have a complex output. It is not a real number. Okay, why? Because see that if I consider that z is equal to minus 1 whole to the power 2 by 3, so therefore z cube divided by 2 is equal to minus 1. Now notice that if we go ahead with the complex number, this minus 1 term is there. So therefore, we can apply, or this identity must have, or this equation must have two complex number solution. Okay, why? Because 1 by 2 is present, right? So directly we don't write that minus 1 here, right? Because it will conflict that property 1. Okay, that's why. Let's go ahead. So here we rewrite it as minus 1 whole to the power 2 by 3, k to the power 1 by 6. And if I apply the limit now, by default, it will be 0, because whatever the complex, the minus 1 whole to the power 2 by 3, it will be complex, real, whatever, right? If we multiply it by 0, it will be always in 0 form, right? So that's why for this particular case, the lip limit is also became 0. Obvious that for the function fx equal to x to the power 2 by 3, the left limit and right limit are equal based on that property 1, or maybe we want to say that limit h tends to 0 gh exists and obviously finite, right? So that's why we'll say that fx equal to x to the power 2 by 3 will satisfy the property number 1, and that's why option B is the correct option. Two more options are left. One is property number 1 for fx equal to mod x, and the remaining one x mod x, right? So first we concentrate about option number C, right? And here we also need to satisfy property number 1. Basically, we need to test for property number 1. So that's why we consider that fx equal to mod h. So therefore, fh will be mod h and f0 will be definitely be 0. We construct the function gh will be equivalent to mod h whole to the power 1 minus half, and that's why it will be h to the power half, right? That's it. Now here, why we able to apply that operation? See that here in the denominator is a function of mod h, and in numerator also, sorry, denominator and numerator I just say in a reverse form, but that's okay. So here we say that if we apply that, we can easily apply that properties, right? So now, with the base, with the basis of this particular aspect, with the basis of this particular aspect, we now apply the limit h tends to 0 gh and take the right limit and the left limit. First, we consider about the right limit. For the case of the right limit, right, we need to apply limit h tends to 0 gh, which will be equivalent to limit k tends to 0 gk with the property that k greater than 0. So therefore, it will be limit k tends to 0 mod k whole to the power half. When k greater than 0, mod k will be equal to k. So it will be equivalent to k to the power half and leads to 0. For the left limit, we consider the left limit h tends to 0 minus gh, which will be equivalent to with the property that k greater than 0, g of minus k. So therefore, it will be minus k whole to the power half. And we, as I discussed earlier, it will be equivalent to again k to the power half, which leads to 0 again. Right and left limit are equal. So therefore, we will say that, therefore, we can easily say that limit h tends to 0, gh exists here and became finite again. So therefore, fx equal to mod x will satisfy the property number 1 here as well. So therefore, option C is also correct. So B, C are correct now. So the last option is need to be tested in. So let's go ahead and test option number D for property number 2. Let's go ahead. So here we need to recall the property number 2 and we consider the function fx is equal to mod h. Now, x mod x. So therefore, fh is h mod h and f0 is definitely be 0. So therefore, if we consider the function, if we consider the function fh, right? So therefore, consider function gh, it will be equal to fh by mod h square, which will be equal to mod h by h, because h is get cancelled, right? That's it. Now, obviously, by default, we can understand that this limit doesn't exist, right? But let's go ahead and test it for the positive and limit sets, right? Right and limit sets. Why I say directly it is not exist? Let's go ahead. So see that, right? We can say that mod h is equal to h when h is greater than equal to 0, and it will be minus h when h is less than 0. So therefore mod h divided by h will be equal to 1 when h is greater than equal to 0, and it will be minus 1 when h is less than 0. So therefore we understand that, right, that limit h tends to 0 plus gh will be given as plus 1, and for the other case when it will be 0 minus, it will be minus 1. So as the right and left limit doesn't exist, so therefore we can say that the limit does not exist. But let's test that again. So here we consider the limit, and for the right limit, right, we say that it will be equivalent to g of k, and then it will be mod k by k. When k greater than 0, it will be k by k. That's why it does 1. For the left limit, it will be equal to g of minus k, and therefore it will be minus of mod k divided by minus k. Therefore, it we can say that, right, it will be equivalent to k divided by minus k, which is equal to minus 1. So therefore, we can see that right and left limit are not equal in this particular problem. As right and left limit are not equal, we will conclude that limit h tends to 0 gh, that is property number 2, will not satisfy for the function fx equal to x mod x. Hence, this option D is wrong. So therefore, for this particular problem, we tested all the options and we make a conclusion that option B and C are correct. And that's it. So it's a straightforward calculation using that little bit of concept of right and left limit. Only one case that right left limit need to be applied properly, other is very straightforward. Okay. So that's it. Hope you understood the problem. Thank you.